For decades, keeping a visual record of our lives meant making deliberate choices. You took a picture, you printed it, and placed it in an album. The organization was physical, intentional, and slow. Today, the friction of taking a photo is gone. We capture thousands of images every year. Our camera rolls are packed with massive amounts of visual data, piled up in a long, endless scroll. But because we capture everything, finding one specific detail becomes incredibly difficult. If you try to look back and figure out exactly which sweater you were wearing to a dinner party 3 years ago, you have to scroll manually for minutes or even hours. We possess the largest photographic archives in human history, right in our pockets. Yet the lack of categorization means most of that data is dead weight. You can't effectively search it for the niche, specific things you actually want to track. To you and me, the camera roll is a messy, chronological timeline of memories. To fix the organization problem, we have to look at those same images the way a computer does. That brings us to a new feature rolling out in Google Photos, a digital wardrobe that automatically groups and curates your clothing without you ever having to manually tag a single shirt. A computer processes this same photo as a raw grid of millions of pixels, each carrying a specific numerical color value. Identifying clothing from this grid is uniquely difficult for an algorithm. Unlike a rigid object like a coffee mug, fabric folds, layers over other items, and wrinkles. A shadow in a crease completely changes the math, scrambling the pixel values the computer is trying to track. Transforming this flat pixel data into an organized digital closet requires the system to translate two-dimensional numbers into a three-dimensional understanding of human context. If we pick a single item out of this new digital closet and reverse engineer how it got there, we can see the exact pipeline required to make sense of the mess. The very first hurdle is figuring out where the clothing actually is. In machine learning, this is called semantic segmentation. Before it even looks for a jacket, the algorithm scans the entire image to draw an invisible boundary, separating the human figure from the environment. Once isolated, it performs a secondary segmentation. The AI draws boundaries inside the silhouette, carving it into specific zones. It isolates the shirt, pants, and bare skin regions. Successfully isolating the shape of a garment is only the first step. At this point, the system has no idea what that isolated shape actually represents. To figure out what the item is, the algorithm moves to the next phase, feature extraction. The system analyzes the isolated mask, hunting for distinct visual properties. It plots mathematical points along the collar's sharp edges, maps the weave's surface texture, and tracks repeating patterns. This solves the lighting problem. By mapping geometry and texture instead of purely color, the AI can mathematically deduce that a crumpled shirt in a dim room is the exact same garment as an iron shirt in direct sunlight. With the features extracted, the machine learning model runs a final comparison. It checks these data points against vast libraries of clothing references until it can assign a specific tag to the item, like denim jacket. Once the tag is locked in, the original photo is automatically routed into the correct folder inside your digital wardrobe interface. It all looks simple on your screen, but that seamless user experience is an illusion, constructed on top of a multi-layered computer vision pipeline analyzing every pixel. And all of this happens in milliseconds. Billions of algorithmic calculations are executed completely invisibly, running quietly behind the app's clean interface. Powering this pipeline requires massive computational infrastructure. The models processing your daily snapshots are maintained across sprawling server networks, originating from campuses like Google's. This specific garment recognition feature signifies a shift in the purpose of a camera roll. By automatically recognizing these garments, the app transforms a massive archive of photos into a structured, searchable index. For years, a camera roll functioned as a passive, chronological list of past events. Now, it operates as an active personal database. You no longer have to scroll endlessly to remember. You just ask the system to retrieve the specific data. By utilizing advanced computer vision to decode unstructured photos, the disorganized memories of your past are now actively powering the utility of your future digital wardrobe.